Are you still mostly printing in PLA, PETG, and the occasional bit of TPU? Well, heat up your build plate and your wallet, because in this video, you're going to discover over 20 new, unique, and functional 3D printing filament types to try for your next project. You'll learn what they're good for, how to actually print them, and most importantly, what benefits they offer over the boring old filaments that you're already used to. Let's get after it. First on our list, we're going to take a look at HIPs, or high impact polystyrene. You can kind of think of HIPs as being similar to ABS or ASA, but with fewer fumes. It has similar impact resistance, great chemical resistance against a wide range of alkalis, alcohols, acids, oils, and greases. It also offers exceptional dielectric strength, meaning that it withstands electrical breakdown. Now, some brands like Filamentum even make food-safe HIPs that can withstand up to 95 degrees Celsius. It's also very affordable. So to be honest, with such a long list of benefits, I'm really not sure why most people don't print this stuff instead of ABS, or why I'd never really heard of HIPs filaments before. It does require an enclosed printer though, so I printed out these samples on the Prusa Core 1. HIPs is mostly thought of as a soluble support material for PETG or PLA because it softens in acetone and dissolves completely in D-limonene. But honestly, you can use it for all sorts of functional applications. I printed out some of these custom brackets that I designed for fire extinguisher balls because I want the brackets to hold up if I bump them, but withstand heat long enough to keep the ball in place if there is a fire. HIPs is also great for things in the kitchen if post-processed correctly to ensure that it's food safe. It also really excels in all sorts of electrical applications and electronic appliances. As for the look and feel, it's honestly very similar to ABS, but it comes in a matte finish, which honestly, even if it were just matte ABS, would make it a very interesting filament for me personally. I really don't like glossy filament. This is definitely a filament that I want to experiment with much more, so do make sure you're subscribed if you want to see some future content on that. Up next, we're looking at another more robust version of a very common 3D printing filament. Meet PCTG, or polycyclohexylenyminidinininithinipinethine terephthalate. Yes, I know that this one has become much more well-known in recent months, so if you already know all about this one, do feel free to use the chapters function down below to skip this chapter. Now, the best way to think about PCTG is that it's like PETG, but better, which honestly isn't saying much. PCTG is significantly tougher. It is more resistant to heat, chemicals, as well as UV, and it has higher clarity than PETG. It even, my favorite feature, has a much lower moisture absorption rate. Best of all, it prints just as easily on an open 3D printer as the PETG that you're already used to. In fact, I suspect that a lot of these PETG Pros and high-speed PETGs that are rolling out on the market right now are actually just rebranded PCTG. Look and feel wise, I find that it's honestly very similar, almost indistinguishable to PETG, but some formulas have a little bit more flex, which does probably explain the higher impact resistance. Now, like PETG, this stuff is great for mechanical components, especially ones where impact strength or clarity are of value to you. You already know what to use PETG for, so you really don't need me to tell you. By the way, I will leave links down in the description as well as discount codes wherever I've been able to negotiate them, should you wish to support the channel, pick up some of these filaments, and support the brands that made this video possible. For number 3, let's talk about PEBA, or polyether block amide. Now, full disclosure, I actually did cover PEBA in a past installment of this series, but over the last months or so, a ton of new companies have started offering it in a wider variety of colors and shore hardnesses, so I do think that it is worth covering again. But as I said before, feel free to use the chapters below if you like. Now, if TPU and TPE are rubbery and absorb impact, you can think of PEBA as bouncy. It has a way higher energy return than pretty much any thermoplastic, meaning that if you squish it, it will pop back into shape instead of slowly relaxing like TPU does. That's why this exact material under the trade name PEBAX is used in things like high-end running shoes. It also stays flexible in extremely cold temperatures. It's very resistant to fatigue, and it's much lighter than most other flexible materials in terms of density. It also tends to feel a little bit nicer on the skin, though it is certainly not as nice as the Ninja Tech Chinchilla that I also covered in a previous installment in the series. Now, printing PEBA is similar to TPU in that you do need to keep it dry and reduce friction on the filament path, but in my experience, it does seem to print a little bit cooler and a little bit faster. Obviously, we don't always want that energy return. You definitely don't want to use this stuff to print a door stopper, but it is still among the best performing elastomers that we can print at home. It's perfect for things like gaskets, vibration dampening parts, wearable components, combat robots, bands, mounts, hinges, springs, and just flexible mechanical linkages that move a lot without tearing. Whereas PEBA used to only be available from the most cutting edge and innovation forward brands like Filamentum, we're now seeing more and more companies like this brand, Symbatron, and even Soriatech coming out with PEBA. So I'd love to know in the comments below, do you actually plan on trying this filament out? And if so, what are you going to use it for? While we're on the topic of PEBA, let's talk about PEBA Air, in this case from Soriatech. Like normal PEBA, these types of materials have been around for a while from brands like ColorFab, but they are only now becoming more available from a wider selection of brands. They include a foaming agent in the filament, which is heat sensitive. The higher the print temperature, the more the material foams, and the more it foams, the lower the extrusion multiplier will be. The net effect is that you can actually vary the hardness of the part using temperature. In this case, Soriatech claims that you can get anywhere from 70 to a 90A shore hardness. The only thing is, that's not the only variable affecting the squishiness of the end part. It will also vary depending on the amount of infill and the number of perimeters. Printing this stuff is honestly surprisingly easy, at least on the Prusa Nextruder, which admittedly is known for its ability to handle flexible filaments. It kind of prints like normal PEBA, besides the need to drastically reduce the amount of friction on the spool and the filament path. So I use this as an opportunity to test out the new feature on the Core 1L, which allows you to bypass the filament sensor, and it worked a treat. The only tricky part is going to be dialing in your extrusion multiplier and your speeds, especially if you're as impatient as I clearly was. Oh, also, because PEBA is already so much lighter than other materials, and because there's 40% less of it by weight, the weight of the end part is actually so minimal that it's gonna present an issue. I actually tried both magnets and stuffing my print full of scrap metal, and it was still too light to actually stay put when removing the lens from this Gridfinity case. I ended up having to modify the design completely to give it even more clearance. All in all though, I think that the end product is absolutely gorgeous. I really love this EVA foam look and texture, but I did wish that it would have come out a little bit darker. Personally, I plan on using this filament in a wide range of situations where TPU just isn't soft enough either in terms of texture or in terms of shore hardness. So I'm thinking like Gridfinity bin inserts or even some multi-material prints where I use PEBA on the inside of different carrying cases to protect my electronic gear. But what if you want the foamy look without the extreme lightweight or the energy return or the slightly lower layer adhesion of PEBA? Well, in that case, you will want to check out TPU Air, like this roll from Fadis or the roll I have somewhere from Soriatech. These are very similar to the PEBA Air that we just talked about. It's just same idea, different base polymer. Now, why might you choose TPU Air over PEBA Air? Well, for one, TPU is about 25% more dense. So if, for example, in the case of my Gridfinity lens cases, you don't really want your prints to easily fly away, then TPU Air is probably a better choice, but the weight savings are a little bit negligible. More realistically, the main reason is going to be that TPU does have exceptional layer adhesion, and as you'll see with some of the PEBA that I tried to print, layer adhesion can be an issue and parts can tear, whereas with TPU, you're really getting that strong interlayer adhesion. Additionally, in some cases, you might not want the material to squish or bounce back so aggressively. Take, for example, a grip of some sort. You might want it to feel soft texture-wise without the springy trampoline effect that PEBA is going to give you. Now, TPU Air sits right in that sweet spot. It's softer and more cushy than regular TPU, but it has less of that energy return and it feels a little bit less alive than PEBA. The printing workflow is pretty much the same here. Temperature controls the foaming, foaming affects the extrusion multiplier, and you will need to fine-tune your speeds to avoid oozing. Now, one of the nice things about these foaming materials in general is that you don't have to worry as much about extruder jams because the extruder doesn't really have to fight to push so much material as it would if you were printing normal TPU or PEBA. I've started thinking about TPU Air as my soft touch grip material, so handles, foot grips, cradles for electronics, anything where I want to feel comfortable and have that non-slip, but without the bounciness. And of course, the foamy texture just looks and feels so nice. It gives everything this sort of premium EVA foam feel that is really, really nice, for example, in toolboxes. Now, before we leave flexibles altogether and get into some of the more engineering grade materials, let's talk real quick about Morphlex by BQ. This flexible filament is similar to the last two that we covered in that it does offer variable hardness, but here it's not for lightweight or for the foamy properties. Instead, Morphlex goes through your extruder at 90A, making it incredibly easy to print on most normal prints, but once extruded through your nozzle, it comes out as low as a 70A shore hardness. That makes it much more pliant and appropriate for shoes, which is what BQ almost exclusively markets it for. I was able to print this on the normal Core 1 without the filament bypass of the Core 1L, but just to be sure, I did print and install this bearing spool roller design I found on printables just to reduce the friction on the filament path. The only thing is, as you've probably noticed with my repeated attempts to print this specific model of shoe, the design calls for them to use 0 perimeters, 0 top and 0 bottom layers, all infill. But as I said before, because PEBA and Morphlex and all of these different flexible materials just don't have the layer adhesion of plain old TPU, they did keep tearing every time my son and I would try to put these shoes on. So probably best if you use a design that is actually tested for this material, like the ones that BQ provides, or if you're gonna print it out of PEBA, maybe put some perimeters on it. All right, in just a second, we're going to get into the more extreme and esoteric of filaments, but I do just really quickly want to thank this video's sponsor, which is Prusa Research. They actually told me not to bother you guys with a traditional sponsor message, so I'm not going to. I'll just say that nearly everything that I have shown in this video and just about everything that I print around here these days is printed on either the Mark IV's, the Core 1, the Prusa XL, or the new Core 1L. I'm a big fan of Prusa and their products, as well as their philosophy, and I'm very glad to have them as a sponsor. So, you know the deal. Link in the description if you want to support the channel and support the companies who make videos like these possible. All right, this video is already getting rather long, so let's go ahead and cover some of the filaments that require a lot less explanation, rapid fire style. Our first rapid fire filament is this Fishy Filament by Fishy Filaments and Filamentum. It's made out of 100% recycled fishing nets. As it turns out, discarded fishing nets are both a huge problem in our oceans and a source of very, very high quality PA6 nylon. So every spool of this is equivalent to about 200 grams of CO2 removed from emissions, resulting in 98% lower environmental impacts. Now, there are two types of this filament collaboration. We have the Porcorno, I think it's pronounced, for flexibility, impact resistance and temperature deflection, and this stuff, Orca, which adds carbon fiber for better stiffness and creep resistance. Now, like all nylons, this stuff is great for a wide range of engineering applications, but you'll most likely use it around your workshop for things like brackets. I printed this cell phone holder for my bicycle, which I need to go about assembling, but generally I think I'm mostly going to be using this for some camera and tripod accessories that need that rigidity and stiffness. Have you ever needed your 3D prints to be slippery? For example, for parts to slide smoothly against one another or against other surfaces. If so, you just have got to check out this PETG-PTFE filament from Fiberlogy. Don't ask me how they did it, because PTFE, also known as Teflon, is notorious for not sticking to just about anything. But they managed to mix in 10% PTFE into this otherwise normal PETG. I actually used this filament to reduce the friction in the hub of my Box Turtle open source AMS when the filament kept getting stuck, and it worked a treat. I definitely need to get my hands on more of this stuff because it is very, very useful. While we're looking at some innovative Fiberlogy composite materials, let me mention this very cool antibacterial CPE, or copolyester. Now, if you don't know about copolyester, I did cover it in one of those previous videos in the series, but it is really quite similar to PETG. This CPE, however, includes silver nanoparticles, which are extremely effective at killing a wide range of bacteria, though I don't think this stuff will kill viruses. In any case, this filament is ideal for anything that will be exposed to microbial growth, so think kitchens, labs, public spaces. Honestly, the next time you print something for others who are going to play with it at a RepRap festival, it's probably a pretty good idea to print it in this stuff, because I don't know where your hands have been. Up next, we're hopping from Poland to Prague to look at this rather clever material from Prusa Research. It is PETG with 40% magnetite. I kind of get the impression that this was developed specifically for one of Prusa's many business customers, because it really is intended for making things like switches, potentiometers, induction loops, and a bunch of other stuff that is way above my hobbyist pay grade. Still, we hobbyists can definitely use this for printing things that need to respond to magnetism, but where for some reason the design doesn't allow you to just embed magnets. Or just in situation where you need weight, because this stuff is incredibly heavy. Just note that unless you have a highly specialized piece of equipment, it is not possible for you at home to permanently magnetize this material, so don't get any ideas. Do me a favor and drop a comment below and let me know what I should actually make with this spool, because I haven't had any good ideas yet. Up next, I feel like I should just briefly mention ASA-CF. When I was a lass, most brands didn't even offer a wide variety of ASA colors, but now we're seeing a lot of major brands like Filamentum and channel sponsor Polymaker come out not just with plenty of colors of ASA, but even colored ASA-CF. Now, as with all the carbon composite filaments, the addition of carbon fiber is going to give you a nicer surface finish, as well as increased heat resistance, in this case up to 103 degrees C, as well as more rigidity, better dimensional stability. It really works great in any situation where you'd normally use ABS, like these boron parts that I printed. But just be careful not to place PCBs against them, because carbon does conduct. However, because this uses ASA as a base instead of nylon or PLA or ABS, it will also withstand the test of time when placed in the sun. We're talking brackets for your outdoor cameras, or your hammock, or fixes for lawn furniture or gate latches. There's really no limit to what you can actually do with this stuff. Just note, and I am only going to say this once because you probably already know it, any fiber-filled filament should only be printed with a hardened steel nozzle. Now, if you still don't like the colors available in ASA-CF, or your application involves electronics, then you might just want to check out ASA-GF, which uses glass fibers instead of carbon ones. This makes it non-conductive, plus lighter colors like white become available. But you do sacrifice some of the heat deflection properties. But what if you want that ultra high heat deflection temperature without the cost or the abrasiveness of ASA-CF? Well, in that case, you'll want to check out this new Fiberheart ABS-HT HF from Tech. It's basically ABS, but it's made to print much faster and withstand impressive temperatures of up to 101 degrees C. It's great for any high heat environment, such as your engine bay, goodies on your dashboard, or parts that go inside your 3D printer's heated chamber. Okay, fine, but what if you need that high temperature resistance, but you can't or don't want to deal with the fumes and warping of ABS? For example, if you're printing on an open 3D printer. Well, in that case, you definitely need to check out the new PLA-HT by channel sponsor Polymaker. It prints more or less like normal PLA, but it can handle a truly blistering 150 degrees Celsius. Now, post-processing is optional, but Polymaker does recommend annealing it if you want that maximum performance. Either way, if you need something that can handle high heat, like this build plate cooling rack, for example, this filament will outperform even much more exotic polymers like polycarbonate and ASA that print in enclosed printers, so definitely check it out. If, however, you want that high temperature resistance with a matte finish and increased rigidity, then you'll want to check out Polymaker's PLA-HT-GF. It's actually the same thing, but it has glass fibers for added rigidity and dimensional stability. And it also comes in your favorite power tool brand's colors, so you know what to do. So you like heat-resistant filaments, do you? Then you might want to check out this little-known PPS-TF, like this spool from YX Polyer. Now, PPS stands for polyphenylene sulfide. Most people think that it's a performance nylon, but it's actually not, at least not according to my research. What it is extremely resistant to chemicals, heat, flames, and UV. This stuff is kind of like a honey badger. It just don't give a damn. It's strong, shrink-resistant, and reasonably affordable. The only thing is, it can be a real challenge to print it. Getting it to stick to any build surface is really difficult. I had the most luck with Magigoo's new Super Grip formula, and additionally, it really needs a heated chamber. The actively managed convection chamber heating on the Core 1L did a phenomenal job with this stuff until the very second that I had to open the door, at which point the layers immediately delaminated. So don't do that. If you can print it though, this is a great choice in situations where you need both chemical and heat resistance, or where there's any risk of fire because it is flame retardant. Does that sound like you? Well, drop a comment down below and let us know what kind of kinky hobbies you're into. For my part, I use this stuff to 3D print some handcuffs. For my kids' police costumes, because they're always breaking the PLA and PETG ones. What did you think they were for? What's that? You want extreme heat resistance and extreme strength, but you also want that metal-like rigidity? Well, you should probably start out by checking out PPA-CF. Made out of reinforced polyphthalamide, which is apparently a high-temperature nylon, it handles a heat of, get this, 190 to 230 degrees Celsius. And it's unbelievably tough. Honestly, this stuff is already overkill for most of the things that you and I would print around our home workshops, but if you're into automotive upgrades, or racing drones, or just motorized toys that generate a lot of heat, this stuff is going to be a great fit. Not least because, unlike the next one on our list, it won't break the bank. You can actually get a 1 kilo spool of this from Tech for about 54 bucks. Seriously? You want
more extreme?
Then you need to check out PPS-CF, the most extreme filament most consumer 3D printers can reasonably handle. This stuff resists heat up to 240 degrees Celsius. It has a rigidity almost as high as aluminum, and it gives 0 Fs what you think about it. Besides being a bit more prone to brittleness, everything that PPA-CF can do, this stuff can do better. Chemical resistance, stability and humidity, flame retardants, emptying your bank account.
Oh my God!
Let's be real. For almost anything you or I would do as a hobbyist, This stuff is very much overkill. But if you want to never have to worry about a part breaking or deforming or dissolving or catching fire, well, I guess it is cheaper than buying your very own CNC machine. All right, one last one. If that was a little bit too extreme for your pocketbook or your printer, we do have PPS-GF or glass fiber available from both Styraiatech and Polymaker. Now the trade-offs here are going to be the same as when we compared ASA-CF to ASA-GF. ASA-GF offered us a bit less rigidity and temperature resistance than its carbon fiber filled big brother, but in exchange it is more suitable for electronics and comes in lighter colors like gray. And it's about 15 to 30% cheaper depending on who you buy it from. So maybe before you go for broke, both literally and figuratively, on PPS-CF, try this one out instead. Hey, I really hope you guys enjoyed this video and learned something. It was a lot of printing and testing and researching, so before you go, don't forget to hit that like button and leave a comment so the algorithm does its whole thing. As always, links to everything that I mentioned are in the description, and a big thanks both to Prusa Research for sponsoring this video and to all of these various filament companies for providing all this filament to me to experiment with. That's all for this week, but I'll see all of you on the next layer.